Okay, our first speaker this morning is Dr. Robert Bjork. He's a distinguished research professor in the Department of Psychology at the University of California, Los Angeles. His research focuses on human learning and memory and the implications of the science of learning for instruction and self-regulation of learning. Among Dr. Bjork's numerous honors, he is a recipient of the UCLA's Distinguished Teaching Award, the American Psychological Association's Distinguished Scientist Lecturer, and Distinguished Service to Psychological Science Awards, and the American Physiological Society's Claude Bernard Distinguished Lecturership Award. He is a fellow of the American Academy of Arts and Sciences, and he's a recipient of the Norman Anderson Lifetime Achievement Award from the Society of Experimental Psychologists. When you've received as many honors and awards and distinctions as Bob, it's easy to lose track. And one which Bob may be unaware of is that one of our speakers today, Jeff Norman, lists Bob Bjork as his personal hero. Please welcome Bob Bjork.
Well, it's great to get a view of this impressive initiative at McMaster. We can only hope there'll be initiatives like this at a lot of universities. I know, in fact, Harvard is beginning one. Michigan has something similar. There's great potential in this kind of cross-disciplinary initiative on a campus. It's fun to get a little view of it for a day and a half. That one is me. So one thing that's been a theme the last 20 years particularly, maybe especially the last 10 years, is research on what people understand or don't understand about their own learning. And that research has documented that people carry around a whole array of misconceptions, illusions about their own learning to a striking extent. There's said somewhere that it's kind of amazing that we don't learn more about learning just from the trials and errors of everyday living and learning, but we appear not to. And what I want to start out with is just a quick overview of some of the kinds of illusions we have. This is a slide I put together, which, without going into details of this, in terms of speed of generation and whether you'll remember giving an answer before, the longer it takes for something to come out, the more you remember having done it. People predict the opposite. Learning several simple skills. If their practice is interleaved, you do better. People prefer that practice be blocked. Spacing, this is a famous study training postal workers on keyboard skills. The more the schedule is spaced, the more you benefit, but the least people think it's good. Something more recently in the domain of spacing that we have been working on is whether people actually know to space. In this experiment, they're given a choice. There's items that are easy, medium, or difficult, and they can choose to which ones to study in a study period that comes sooner or comes later, and we control for final retention interval. And the more difficult, we also showed the more important it is, the more people choose to study it sooner, which, as you know from John's talk, is the opposite of what they should do. Test effects that John also referred to. This is from a well-known study by Roediger and Karpicki, in which they compared repeated study with one study session and repeated tests. And on the short term, it looks better to have repeated studies, but on the long term, you're better to have that followed by repeated tests. But then they ask people, rate how much you'll remember in 1 week's time, and the participants think they'll remember twice as much when they study. So again, something that's backwards. Another one, this case, Karpicki and Roediger, different schedules of testing and studying. And in those schedules, asking people how much you recall in 1 week, they said these different schedules about 50% in all cases. And the actual differences are this big. So basically, there are predictions there, and they're insensitive to manipulations that make that big a difference. Recently, we've looked at the roles of testing and facilitating subsequent study, and a major issue is, well, what about if you make errors on tests before subsequent study? And we and others have been able to show that even in a case like this, where you try to predict what associate of a given word is to be learned, in this case, whale, and then you see what it is, this is set up so they're wrong 97% of the time, and we compare later cued recall when they see whale and have to try to recall what was paired with it, with a case where they spend the whole time studying. In this case, where you replace some of their study time with an unsuccessful test, produces better memory at a delay. But do people appreciate that? So in work at Columbia by Hulzer and Metcalf, they replicated this experiment, but afterwards asked them which helped you learn better. And as you can see, the actual results again for generating the error was better. They predict just the opposite. And this is after they've been on the final test. So people carry around beliefs that more studying would be better. They carry around a lot of beliefs, and a lot of them are wrong. In this project, we decided to look at could we sort of mend a metacognitive illusion that turns out to be a really powerful and striking one. This is a sample of what subjects saw, an experiment by Nate Cornell and myself, in which they had to learn the styles of different painters from examples of their paintings. So these were not shown simultaneously, but one at a time. And so they might see a painting by Lewis, another painting, another painting, another painting, until they'd seen 6 paintings by Lewis in succession. And that would be a blocked presentation. Or they might see Hawkins 6 in a row. But the 6 of the 12 artists were presented in that way, their 6 paintings. But the other 6, the paintings were all interleaved. So when you saw Pisani here, you didn't see another Pisani until you had studied other artists in between. So the crucial thing now is this is inductive learning. So on the final test, you see brand new paintings, ones you did not see before. And then using this selection, you have to select what artist painted that. So it's a matter of learning their styles. This is not sheer memorization, because the test doesn't include anything exactly that you saw. It's a test of categorization, inductive learning. And in this case, they got feedback. If they picked one, they could see that they were correct, or if they were wrong, they could see who the correct artist was. Now, contrary to a famous quotation by Ernst Rothkopf that spacing is the friend of recall but the enemy of induction, the logic behind that is if you're going to see similarities, things should be next to each other. We actually find a major benefit of interleaving, and this sort of replicates over and over again, not just with these materials, but also with butterflies, birds, novel objects, children, and so on. But what made this have quite an impact is at the very end of the experiment, we asked people, which do you think helped you learn more, the masked or spaced presentation of an artist's style? And so those were the actual results as far as number of subjects benefiting one way or the other. This is what they said. So there's a powerful effect that this blocking is helping learning, and that the interleaving is creating some sense of confusion and so on. So why is this preference so surprising? Well, one thing is it comes after a test in which people have just done better on the interleave. But also there was feedback. They could see what the correct was. That should again help inform them and perhaps give them some impression of the benefits of interleaving. Why is it so strong, this preference? Well, participants can be misled by a sense of fluency. If this were a longer talk, I would have shown you a sample of these materials, and when you see it blocked, you feel like I got it. I got I got Hawkins, I got Lewis. When they're interleaved, there's a sense of trying to sort it out, a sense of confusion and so on. So your subjective experience can mislead you. But beyond that, there's now evidence they arrive at the laboratory with the belief that blocking's better. And so this is a nice experiment by Tauber, Dunlosky, Rawson, Walheim, and Jacobi, in which they looked at people learning families of birds. So, for example, there might be 3 different jays that they're learning from those examples. But the clever thing in this experiment is the participants could choose their own schedule of seeing these paintings. So they would see a screen like this that said you just studied a jay, click on the bird family you'd like to study next. So they could study a finch or a grosbeak. Overwhelmingly, they choose to see another jay. In fact, they pretty much exhaust the set of jays before they go on to anything else. So people come to this situation with the notion, when did I start, incidentally? Okay, I've lost track of the time, all right. They come to this with the belief that blocking is better. So this is what we're going to take on is what does it take to try to disabuse people of this impression or this belief. This is a project led by Veronica Yan, whose picture's there and her body's over there. And we tried to take advantage of kind of conceptualization came out earlier with work by Asher Koret and myself, that you can manipulate experience-based, trying to correct. You can try to give people some sort of experience that would inform or change their mind, or you could give them some sort of theoretical framework, some conceptualization that might change their mind and sort of dislodge these erroneous beliefs. And just a quick example of in the case of Asher Koret and myself, we were interested in trying to get rid of people's foresight bias. What is foresight bias? Well, if you look at these pairs and we ask you, what's the likelihood the second word will be given as an associate to the first? You probably won't be surprised that it's 0.71 in the case of lamplight. It's strongly associated. So is find seek, and that's 0.03. Sell buys 0.56. Cheese cheddar 0.03. And then citizen tax is 0. Well, these pairs are pairs where the association is very strong in the forward direction or the backward direction. And then we made up some that Asher gave this awkward name, purely a posteriori pairs, meaning that we made them up to look associated, but they're not in the norms. So what happens when you have people study these materials? It makes a big difference for later recall whether the association goes from the cue to the target, but do people, in terms of their ratings, understand that? So for example, we call this foresight bias a sort of illusion of competence that comes when you're making a judgment in presence of the answer about your performance later when the answer won't be there. And so in the case of cheese cheddar, for example, there's a strong association, but at the time of a later test, cheese will trigger other strong associates, such as mouse, bread, wine, and so on. They will compete at that time. But can you put yourself forward in time to imagine the situation where there will be that competition? Or sort of more educationally relevant, you're a kid in the geography class learning that I almost made the error, that Canberra is the capital of Australia. Can you put yourself forward to imagine the test when you'll be asked that, and other things like Sydney and Melbourne and so on will come to mind? So in an actual experiment of this type where people get presented these forward, backwards, and purely a posteriori pairs, you can see that they predict the same level of recall for forward and backward, a little lower for those pairs, but then actual recall differs a lot. And so the question is, what sort of experience or theory might overcome this kind of illusion, might inform them and sort of, in our language, de-bias this foresight bias. And so, without getting into details, we ran this experiment looking at whether simple experience across a study-test series would gradually inform them. Or what about a theoretical intervention where you explain, give them examples of forward-backward pairs, tell them something that amounts to a theory of the foresight bias. And when we did that, we also combined that with whether a new block of trials would use the same pairs they had or would use different pairs. So would the experience or the theory transfer to the same pairs, and would it transfer to new pairs? And this is just saying what I said. And the important thing is, as far as just the experience, which on this table is called mnemonic, if it's the same pairs in the second block, you transfer, you learn, and you transfer. This is study time. You adjust your study time appropriately. If, however, it's a new set of pairs, your experience leads you to be sort of back where you were. Now, when it's a new set of pairs, this is a difference. Sorry, I'm getting a little too fast here. This is a difference in the study time allocated to backward pairs and forward pairs. And the more you've adjusted to the difference, the bigger that should be. And so if it's the same pairs, either in the theory case or the experience case, you adjust appropriately on the second block. But if it's new pairs, you don't adjust at all based on simple experience, and you adjust about halfway based on the theory. So it looks like it required a combination of both the experience and some sort of theoretical biasing, debiasing techniques. Okay, now quickly to our study. How much time do I have left? I forgot to see when I started.
You're at 16 minutes.
Okay, I'm at 16. Good, okay. So what does it take to overcome participants blocking in the painting study we went over? So one of the manipulations we did was in this vein of a sort of theoretical debiasing. So we ran the standard experiment, just exactly like I said, 6 exemplars, 12 artists, half block, half interleaved. The test is on new exemplars. But then afterwards, there's no special instructions before we ask them what schedule led to better learning. This replicates exactly Cornell and Bjork. In this case, we tell them before they predict that 90% of participants actually do better with the interleaving. Which one helped you learn better? And one message that will come out of this, incidentally, not just this study, but other, people are incredibly willing to believe that they're in, about 80% of people willing to believe they're in the 10%. Somehow, you know, I think it traces to learning styles and other kind of things that very willing, well, that's true of most people, but for me. In this case, we actually kind of mix it a bit. We tell them 90% do better in interleaving, even though massing feels better. We really give them more. And then in this last one, which we think of as everything conditions, really heavy-handed, 90%, even though massing feels easier. And then we go on to an explanation of that why interleaving is better. It enhances discrimination and so on. And here's some of that text that really is heavy and basically telling them everything we know based on the research about it. Then we say, well, which help you learn better? So anyway, this is then combined in the 3 experiments. The first was a replication basically of Cornell and Bjork, except that there's these questions. Given the results of that experiment, we thought, well, maybe they just aren't very clear at the time of test which ones were presented interleaved, which ones were presented blocked. And so in experiment 2, At the time of the final test, we asked them this question. In the study phase, did you see the paintings of this artist spaced or masked? So try to make them tie their test experience to the spaced mask manipulation. And in the third experiment, given the results of this one, we got a little more heavy-handed on that dimension by presenting a given artist's paintings on a white background like that or a black background like that, and then at the time of the test it was white or it was black. Trying to, okay, some are going to be in this background, they're going to be intermixed with others, some are going to be on that, they're going to be blocked, and then, so a kind of heavy-handed which artist was which and try to tie their experience at the time of test. Okay, the results are pretty much the same across experiments. Let me focus on experiment 2. So here's where there's no instructions to the participant. This just shows their actual, which one they were actually better on. This is their judgment. So nobody said interleaved was better here. Some say they were about equal. In spite, of course, the fact, again, that they've just, in all 3 experiments, we replicate almost exactly the benefits of interleaving that Cornell and Bjork found. So in spite of that benefit, nobody says interleaving's better. This is the 90% condition. Now there's a few people who say interleaving, a few more who say equal, but still most people say blocking. Here's 90% with the fluency explanation. Didn't seem to change people very much. Now we did manage just barely with the fluency and the theory to get this advantage of interleaving over blocking. Now, an interesting thing came. This is the experiment in which we have them say, after they try to say who the artist was that artist's painting blocked or interleaved? And this is basically the pattern depending on whether they were correct or not. It shows how strong this kind of misconception carries along. If there were identified the incorrect artist, they tend to think that artist must have been interleaved. So they carry, they're actually, when they're correct, they're slightly better with the interleave, but they sort of carry along this powerful sort of notion that if I was wrong, it must have been that case that seemed confusing. And instead of what we were trying to direct them to is, hey, I'm doing better on the ones that were interleaved. So why is the judgment that blocking enhances inductive learning so difficult to overcome? Well, we've alluded to it a bit. If you're in this experiment, you will have a sense, as I mentioned, of fluency that comes from seeing 6 paintings in a row. And there's a whole body of research in the cognitive literature on how people get fooled by the sense of fluency. A lot of the conditions that turn out to be poor for long-term learning give a sense of fluency of something coming quickly to mind, something looking very familiar, and so on. So we're at risk of interpreting fluency and familiarity as learning and understanding. The rereading example that John gave, I mean, we know from research that whether you have understood one thing or not from a given chapter as a student, when you come back and reread it again, low-level priming effects will make your reading more fluent. It's just a very low-level perceptual thing. It will seem more fluent. That can be confused with your feeling that you've got it, that you understand it. So this is one dynamic, but interestingly, as the Tauber et al. Experiment shows, people come to the experiment with an entrenched belief that blocking's better. One thing is it just seems as analogous to the Rothkopf quote that spacing's a friend of recall, but the enemy of induction, that would be the enemy of induction, seems sort of intuitive and logical. Actually fooled Cornell and Bjork in designing the experiment. But look at this. If you just think about it, blocking is everywhere in the real world. These participants come and their schooling experiences included the fact that their instructors or trainers in skills, whatever it is, have blocked. And you can say, well, they're teachers, they're trainers, they must know what they're doing, so that must be the thing to do. And we've had annually at UCLA, there's a symposium on the science of learning medical education. They're very interested in the interleaving blocking things because everything they do in the medical school is, here's one example of this malignancy, here's one example of an x-ray that's got this, here's everywhere it's blocking because it fits people's intuitions. So in a recent annual review article by John Dunlosky, Nate Cornell, and myself, we have a section on what all it takes to become sophisticated as a learner. What are the challenges? And in that, we sort of point out that it really is no small matter to become optimal in self-regulated learning. And take advantage of this conceptualization that we have to monitor our learning, make judgments whether we've acquired something or not. Given that monitoring, we have to control, we have to choose different kind of activities. And then if we think of there's an acquisition phase, and then there's some retention period, then there's the time of retrieval when it matters, when you're tested. All of these have been topics of research: ease of learning, judgments, feeling and knowing, and so on. To be really good at this is a challenge. But I think one thing the work I've talked about today shows there's also a kind of overlay that comes, the belief structure. Before you even start thinking about the monitoring, control, and so on, these beliefs that we compare, that we bring with us from the trials and errors of everyday living and learning, are going to make acquiring, becoming optimal in this sense, fairly difficult. So the final point is, I think this illustrates the challenges we confront in terms of students becoming more effective stewards of their own learning, the sense that everyone's an individual, and yes, you're telling me things that apply to most people, but not to me. That's a kind of belief that we confront. And then, of course, from our standpoint of being teachers, we too are susceptible to this range of illusions. We're susceptible to creating the conditions that make people improve rapidly but don't support long-term learning. And I think, as the director of this program said so eloquently at the beginning, that this is going to take, we as cognitive scientists have a major role to play here, but this is a real challenge to confront all of these aspects. And with that mixture of negative and positive comments, I want to thank you very much.